Hello everyone, this is the Mining Geologist and I am back again with another very exciting and very informative tutorial. The recent tutorials, they were like a series of tutorials that they are linked together, and most of them we've seen how to use Python, and that's all based on what you guys requested, and I will keep on sharing a lot of cool stuff using Python in the upcoming days. So far we've seen how you can create a Python DEM web application, which is an application that you can use to download digital elevation models for any location on Earth and clip that on the fly. Then you can use that DEM in whatever application or software that you want to use, maybe QGIS, maybe ArcGIS, or any mining package that supports digital elevation models. And then we've seen also how you can use these digital elevation models to with another free software and open source software, which is Area Load. And you can use that to create cool looking 3D maps, which is this tutorial in here. And a lot of you have enjoyed that tutorial and you want to see some cool looking maps and so on. So I thought about something. Why don't we create our own 3D mapping software? Yes, it is possible. And in this video, you will see it's not really that complicated. That's my promise to you. So in this video, we'll be creating a simple software like this one that allows you to import your digital elevation model, DEM, and create digital terrain models or DTMs like this one in 3D. And you can change the colors, you can view contours, you can filter out certain elevations. We'll see that in this video. And all of that in just 10 lines of code. So stick to the video to see how you can do this one. Okay, let's get started. So I'm going to walk you through the code that you can see right now, which is the exact same code that I used to create that cool application that I showed you in the intro. And as you already guessed it, and as you already noticed, we have just 11 lines of code. Yes, with 11 lines of code in Python, you are able to create a cool application like that one. And that's why I really like Python, and that's why I really advise anyone to go and learn this amazing programming language. And a good starting point actually is this channel, because not only you will learn the basics of Python, but you're going to be applying that to things that are going to help you in your daily job routines. So we've created an application that allows you to download DEMs, and we've created an application that allows you to create EDAs reports automatically from your data set. And now we are going to create an application that allows you to visualize DEMs in 3D. Okay, so let's look at these lines one by one. So the first one, we are importing the library NumPy, which is numeric Python that allows us to manipulate matrices. Why do we need this one in this tutorial? Because we are going to be using some raster data. So if you look at the raster, in our example in here, we're talking about DEMs. DEMs are rasters in which we have the elevations. So we have the information of the elevation inside that raster. And if you look at the raster and think of that as a matrix, so you have the different pixels, you have the different rows and columns of the pixels, and each one of these pixels contains the elevation data. So we can think of that as a matrix, and we can manipulate that using NumPy. So we'll see in a moment an example of that. Then we have Rasterio. Rasterio is a library that allows us to access information stored inside the raster data. And we're talking about spatial data. So Rasterio allows us to access spatial data inside raster. So there are plenty of other libraries that allows you to manipulate images, either to clip them or access different kind of informations. But Rasterio is mainly used for, these kind of GIS applications, okay? So it's a good library. You can go and check that out and see all the different things that you're able to do with this library. Okay, the next one is a really cool library. It's Mayavi. Mayavi is a library that allows us to visualize things in 3D. So if you have a mesh or what we call a wireframe, you can visualize that in 3D using Mayavi. Not only that, but Mayavi creates like a cool interface for you that allows you to do a lot of other different manipulations that you don't have to code them, but you have access to them later on when you visualize that mesh. So we'll see in a moment one of these examples. So let's go and see what the first line is doing here. So I'm sure that you already guessed it. So it says subscribe to Mining Geologist. We used MLab, which is the Mayavi in here. We've imported that as MLab. Dot figure, it's you'll see in a moment when we load that 3D window, we have like some sort of a title. So you can call it whatever you want in here. And I called it subscribe to Mining Geologist. So please, guys, subscribe to this channel. If it's the first time that you see this channel, it's all about mining engineering, geology, and geoscience in general. I share here a lot of cool tips and tricks that you can do with different commercial packages, open source packages, or creating your own packages and tools in Python. So the next line in here, it's really simple again. So we're using Rasterio. We use it this way with Rasterio open. So we are going to use Rasterio to open a DEM raster file, which is stored in my local system called test.tif, which is a raster that I've created using the previous tutorial. If you guys remember, we've created an application that allows you to download DEMs for any location on Earth and clip them on the fly and then download them to your local system. So with a combination with this tutorial, we'll be able to visualize these DEMs in 3D, and that's really cool. So one tip here is that if the DEM is not in the same folder as your script, make sure to put in the full path in here for this method to work. And then we're importing this one as SRC, which is like a temporary variable. You can call this whatever you want. But then what we're doing here is that we're using the method read1, which allows us to access the elevation information stored in the raster. Okay, so we've accessed the DEM, which is a raster. Then with src.read, which is the temporary variable here that represents this one, the data inside this one, we read these elevations and then we store them inside a variable called elev in here, okay? So if we go and look at this elev variable here, so we see how it looks. So if you remember, I told you to think about the raster as if it is a matrix, and this is how the raster or the different elevation data look like as a matrix. So you can see here, for example, 92. 92, this one is the elevation stored in the pixel that is on the top left corner, okay? This one is 74, which is the elevation stored in the pixel that is on the bottom right corner. Okay, so we get the idea how you think of the raster as a matrix, and that's why we need NumPy to manipulate these matrices. Okay, so just keep that in your mind. Okay, so another thing that we can use, which is shape. This one is going to show us the shape of this matrix. So how many columns and how many rows. Because you can see these points in here, which means that we have some missing columns because we cannot visualize the full thing. We'll see in a moment how many rows and how many columns that we have. And this one means that we're not showing all the different rows. So these are the first three ones, and this is the last three rows. So let's go and look at the shape in here. Okay, so the shape we have about 2,480 and by 3,507. So now we know what is the shape of this raster. What we can do now is we can assign these two values to two different variables at the same time. How can we do that? It's really simple. So the first thing that we need to do is we create a variable called n rows and another one called n columns, which is the number of rows and the number of columns. Okay, we assign that to lf.shape, which is a tuple. Since we have like two different values in here, so this one is going to be assigned to this one, and this one is going to be assigned to this one. So let's go and confirm that. So let me comment this out. And if I go here and say print n rows, for example, you can see that n rows is now equal to 2,408. So that's what we need. That's the number of rows. N columns is equal to the number of columns. Okay, so I hope that everything is clear so far. Then we have another method in NumPy that allows us to create a grid. So if we have the different x values and the different y values, we can go and use this NumPy mesh grid to create a grid with x and y values. So the only problem now is that we know the number of rows and the number of columns, but we don't have like a variable that is storing like all the different y's and all the different x's. So to do that, what we can do is we can use this numpy.arrange, and I will show you what this one is doing exactly. So if I go and say print numpy.arrange number of columns, okay? If we remember, the number of columns was 2,480. Like number of columns, yeah, let's go and look at the number of rows. It's the same thing, but we're using the number of rows in here. Okay, so what this one is going to do, it's going to take that number and create a list or an array, what we call an array, with different values all the way from 0 all the way to that final number here, which is, since we started from 0, then the last one is not going to be 2,480, but it's going to be 2,479. Now, if we have this one, and we have the other one for the number of columns, we are able to create a mesh grid. So how does that looks like? So we have just one row for the x, but you want this one to be all the way repeated by the number of columns. So this is the number of rows. We need this to be repeated by the number of columns to create a matrix. So mesh grid is going to do that for us. So let me go and look at this one. If I go and print, for example, the x, you can see now that we have that same row repeated with the number of columns, and you can see the same x column, the same x, but now if you look at the y, okay, it's not this way, so let me go y. Now what do we have in here? We have that same y column, but is repeated with a number of rows. So, and this one allows us to create a grid with all the different x and y's. What we're missing now is the elevation, but we don't have to worry about that because the LF already stores a matrix with the same shape that contains the elevation. So what we have to do is either to use it directly, or we can assign that to another variable called z, which is going to store the elevation, and we've already seen how the elevation looks like. So now we have the last part in here, which is using mlab.mesh to create a triangulation out of these X, Y, and Z values. And it's easy as saying mlab.mesh, and you give it the X, Y, and Z arrays, and it's going to create a mesh for you. Okay. So, yeah, one simple advice in here, when you're trying to create this one or use this method, I really advise you not to use it like if you go and download a DM from USGS, it's going to be like a really large data set with a lot of variation. And if you use it this way, and and especially if it contains a lot of pixels, you're not going to see something that you like. So I really advise you to use the method that I showed you in the Python DM tutorial, or you can go and download your own DM and clip it in a GIS software so you have like a smaller area, and that way it's going to look better. So now let's go and take a look at the results. So this one might take some time based on the data set that you're using and your computer for sure. So just wait. It should not take more than 30 seconds or 1 minute. So we'll have the view in a moment, and there you go. And you can see that we have a really cool looking 3D view of that raster, and I'm already happy with the results. And so the cool thing about Mayavi is that you don't have only the 3D view, but you have like a widget, and each you have access to different kind of things, and we'll see these in a moment. So you can see the toolbar in here. So let's skip this one for a moment. You can see that you view different views in here, and you can go a perspective view or isometric view, and it's either one of them. And you can see that we have like the different axes in there for your reference. And you can go and click on this one to view this on full screen. You can save a screenshot, and you have access to different features in here. But what I really like is the Mayavi pipeline, which is this one. So in the Mayavi pipeline, one thing that we can do, for example, is if we go to this surface in here, which is this surface, and by the way, you have different kind of things in Mayavi you can visualize. So surface is one of them, and we can go and convert the surface into contours. So maybe we are interested in contours, not like a 3D surface. And we are able to view the contours in 3D, which is really a cool feature. You can see that we have contours in here. And we have now the number of contours. We have 10. We can set this to whatever number that we want. Maybe you want to see 100 contours. Maybe you want to see just 20. So it's really up to you. And another cool thing that I really like, so if you want to fill these contours, maybe you want to just 10 contours and you want to fill them, you can go and click on this one here, and it's going to fill these intervals using a color map predefined in this color and legends in here. We'll see in a moment how you can change that. Okay, and there's a plenty of options that you can change in this one. And the cool thing is just this whole thing, we have access to all of these features by just typing 10 lines in an editor. It's really amazing, and it's really mind-blowing. So you can see that we have the different colors in here, and we can go and change that. Maybe we want this to be a terrain. We can go and change that to a terrain. We can go and change this to this one. So it's really up to you and your use case. So maybe in my case, terrain is good. We can go and show legend. You can also go and customize, change the number of labels and the shadow, stuff like that. You can go and manipulate this one if you want. So I'll leave that to you guys. And let's go and hide this one. If we go to surface, one thing I really like about this one, it's a cool feature, I think, and I'm sure that's going to be very useful for you guys, is that the ability to filter out some elevations. So let's say, for example, that we are interested in just in this area and want to get rid of everything that's below a certain level. So we can do that here. So I'm going to set the minimal contour. We can also do the maximum contour. Maybe you want to filter out this mountain in here. Maybe you want to see just everything that's flat. So you can do that by setting the minimal contour, and this one is going to get rid of everything that is below that certain elevation. And you can see that we get this look in here, and you can go and take screenshots with this one, and it's a really amazing feature. So and you can go to this one. I think you can record videos also, and you have access to different modules, so you can go and play around with these. So you have like volumes, and you have ISO surfaces, labels, and scalar cut planes, and you can go like make slices, and I've used some of these, and they are really cool. And again, I can say what I want to say is that all of this was just few lines of code, just 10 lines of code, and we almost created, a small GIS software that allows you to display data in 3D. And one example, or one thing that you can use with this one, other than using it in your daily work, you can go and create something and share this on LinkedIn maybe, and that's one way to grow your network and show people what you're capable of doing. And you can go and you do something like that. You can tag me, for example, and I can go and comment and tell you what I think about this one. And that's one way to attract my followers, for example, to look at your work, and maybe someone might be interested in what you've done in the previous in your previous posts, and you might get a job or might get a promotion or something, and that's a win-win for both of us. It's one way to share that that I do these kind of things, and I help you with your growth on LinkedIn. So that's it, guys, for this tutorial. I hope it was informative. I hope you've learned something new. Please let me know in the comments below. It's free. You don't have to pay for anything. So comment below, subscribe, and let me know what are your needs, and if you like these kind of things or not. And with that being said, see you on the next one.
Just here to show you all the things that you might have missed. He's got plenty of software tips and tricks for your geoscience lives. So get